Hello and welcome to Required Practical 3 Part 2. Let's have a look at the equipment that you're going to be using. You will have 3 cells and you can see that I've lined them up next to each other and connected them next to each other, so it's really easy to see that they're all pointing in the same direction. We've got 2 resistors, we have 1 ammeter which we will connect in series and 1 voltmeter which we will connect in parallel. So the first thing that we're going to do is we are going to complete the circuit using the first resistor, or R1. And we're going to measure the potential difference across the whole circuit by connecting the voltmeter in parallel, and we do that by double-deckering the leads at each end of this battery of cells. So once the whole circuit is connected, we can see that the ammeter is connected in series with the resistor, the voltmeter is connected in parallel by double-deckering the leads. Once we've got the circuit connected, we can take a potential difference reading off the voltmeter and a current reading off the ammeter, and we will record that into our results table. So for R1, we've got a potential difference reading in volts, a current reading in amps, and then we can calculate the resistance of R1 using R equals V over I. So this is for our series circuit. Once you have recorded those results, you're then going to disconnect the circuit and you're going to replace resistor number 1 with resistor number 2. Once you've reconnected the circuit with resistor number 2, you're going to repeat the process of recording the potential difference for R2 and the current for R2, and then you can calculate the resistance using R equals V over I. Okay, final thing that you are going to do is you're going to disconnect the circuit again, and this time we are going to build the circuit with both resistors connected in series. So you can see we've connected the 2 resistors together, and we can see there are no separate branches around the circuit, so we've got 2 resistors and an ammeter in series. And once again, we're going to record the potential difference when we've got both resistors in the circuit in series, the current when we've got both resistors in the circuit in series, and then we can use R equals V over I to calculate the resistance in ohms. The other thing I'd like you to do is add up your 2 results, or the 2 resistances for R1 and R2, and compare totaling these 2 results with the calculation of R equals V over I for this column to see if we get the same figure. So for the second half of this practical, we're going to set the circuit up slightly differently. So you can see I've got my voltmeter here and I've double-deckered the leads across the cells so I can take the potential difference for the whole circuit. I will connect the first resistor up with the ammeter. So we've got the ammeter connected in series, the voltmeter connected in parallel again, and 1 resistor in the circuit. And what we want to do now is take the second resistor and connect that in parallel this time. So the last circuit we looked at, we had the 2 resistors in series. This time we're going to connect the 2 resistors in parallel. And we do that by double-deckering the leads in the first resistor. So, like before, we've got our circuit with the voltmeter and ammeter, 3 cells and 2 resistors, but this time the 2 resistors are parallel to each other. So what I'd like you to do is, actually you won't need to record the potential difference in the current for each of the 2 resistors individually. You can just use the same results as you had last time. And this time we're going to record the potential difference when they're both in the circuit, so the potential difference off the voltmeter. We're going to record the current off the ammeter, and then we're going to use R equals V over I to calculate the total resistance for the circuit. Then we're going to compare it to when the 2 resistors were connected in series, and we can also see if adding the total resistance for each individual resistor is equal to the total resistance of the circuit again, just like we did with the series circuit. And then we will try and have a look to see if resistors behave the same in a circuit when they're connected in parallel as they do when they're connected in series. Okay, now it is your turn.